Hi, my name is Siraji Dar and I'll be presenting the Lines of Charge lab for Physics 2212. So in this lab, I'll be going over 5 sections, beginning with the introduction. Next, I will go over the key assumptions and provide a recap of the data and results of Lab 1. Finally, I will display the computational model of the charge tapes using GlowScript and answer some final questions about the experiment. Here in the introduction, we want to obtain a more accurate estimate of how much excess charge is on one piece of charged clear tape. And in order to do this, we need to treat each segment of the U-tape as a point charge instead of assuming the tape acts as a single point charge. Some of the principles we will use include Coulomb's law in order to calculate the electric force. We will also use Newton's second and third laws to calculate the force of gravity and assume equal and opposite effects of the electric and gravitational forces. Finally, we will use superposition, which is the concept of using segments of point charge to model the electric field and then sum them together. Here is a brief description of the results of the lab, which will be covered further in the upcoming slides. So this lab required some major assumptions to be made. One of them is to ignore air resistance on a moving object. Another is that the U-tape can be divided into segments, with the charge evenly distributed along the length of the tape. Finally, we are going to assume that each segment can be treated as if it were a point charge, with each segment having the same charge. So now we will do a recap of the data and measurements obtained in Lab 1. The length of one piece of tape is 0.2 meters. And given that the mass of clear tape is around 1 gram per meter, the mass of one piece of tape is 0.0002 kilograms. The distance between the two tapes is approximately 0.028 meters, calculated after averaging the results of 3 trials. In order to calculate the gravitational force, simply multiply the mass of the tape by the gravitational constant to get 0.00196 newtons. And since the electric force must balance with the gravitational force to make the tape float, the electric force is also equal to 0.00196 newtons. Finally, these values were used to calculate the charge on the tape, which was equal to 1.31 times 10 to the negative 8 coulombs. Now, let's look at my computational model of the lab to get a better idea of what's happening. The code on the left shows the constants used, including the physical constants and the measurements performed in Lab 1. Below the constants is the function that allows us to find the magnitude of the electric field. The code on the right shows a function that creates a line charge for the model. As we continue through this GlowScript model, we see a piece of code that displays a nested for loop, which utilizes the concept of superposition by iterating through each of the 100 segments, adding the electric fields of each to yield a net electric field for the tape. Then, the code creates arrows which show the electric and gravitational forces, and finally prints the magnitude of these values. In the picture on the right, we see the conceptual model, which shows the green arrows that represent the 100 individual electric fields created by the segments of tape. The white arrow represents the vector for electric force, and the yellow arrow represents the vector for gravitational force. We see below the diagram that the magnitude of electric force is equal to the magnitude of gravitational force. So finally, let's go over some final questions about the experiment. In answering the questions, we see that the estimated value obtained through the point charge model is quite different than the value obtained through the line charge model. These estimates differ because of the different calculation approaches. Specifically, the point charge calculation only took into account the y direction, whereas the line charge calculation had to take into account both the y and the x components of the electric force on the top tape. Thus, the value produced by the line charge model is closer to the real value because it more closely models real-world conditions regarding electric force through the implementation of the concept of superposition.